All right. Hi everyone, I'm RCR Sulagna Saha and I'm pleased to introduce Rohde and Schwarz Koepp, who will walk us through today's presentation on Wi-Fi 7 multi-link operation, a key enabler for ultra-high reliable Wi-Fi 8. But before I hand things over, a quick reminder to submit your questions at any time. We will address as many as we can during the short Q&A after the presentation. Over to you, Joerg.
Yeah, thank you very much, Sulagna, and thank you very much for the opportunity to be again part of the RCS Wireless Wi-Fi Forum. As Sulagna mentioned, I would like to talk today about Wi-Fi 7, especially multi-link operation, and I would also like to give a kind of link or outlook in the direction of Wi-Fi 8. So finally, my mission today is that you, after this presentation, know all the nice abbreviations that were introduced by the standardization, the 11BE standard for MLO. Just for the people in the audience which know Rohde and Schwarz just from this famous security scanners on the airports around the world, I would like to give you a little bit history on Rohde and Schwarz so that you understand why we are talking here about Wi-Fi. As you can see here, we started with Wi-Fi test solution already in the early days of Wi-Fi. So initially with vector signal generator, vector signal analyzers, which are typically used in the early development of chipsets and components. We had also initially a protocol tester. In the meantime, we provide more or less the whole portfolio for RF measurements for several wireless technologies, but also for Wi-Fi. Which includes, again, signal generator, signal analyzer, but also so-called one-box signaling tester, which are mainly used in verification, validation, and in mass production, and also in signaling mode, where you also look on the higher layers. As you can see on the marks here, we providing also already today Wi-Fi 8 test solutions. So these solutions, like our generators and so on, are in these days used by chipset vendors to develop the latest Wi-Fi 8 chips, even that the standard is not yet finalized. So this just as introduction, that you get a little bit picture of what we are doing. What is not shown here, by the way, is our conformance test systems for regulatory testing in this unlicensed bands. So coming now to Wi-Fi 7, we heard already a couple of things about Wi-Fi 7 and how this makes progress on the market. And Wi-Fi 7 was all about extreme high throughput. Essential for this were optional physical layer features, especially the 320 megahertz channels, which is available at least in some countries in a 6 gigahertz band, then the availability of 1496 QAM modulation, and still 80 by 8x8 MIMO. As you can see here, theoretically on the physical layer, you can achieve with this configuration more than 20 gigabit per second, what we call extreme high throughput. That's nice, but in the end of the day, this is something that you can achieve on the max limit on the lab environment. For the user, finally, it is all about the experience. And the experience is much more than just the peak data rate. Users would like to have a stable Wi-Fi connection for exactly the applications that they are actually using. That could be high density access in certain areas, in the venues, in the stadiums, and so on. They would like to have minimum latency if they are playing, for example. You would like to have a reliable connection, even if you are on a train or something like this. There are applications in the industry environment, and not to forget energy efficiency is always in topics, especially with our battery power devices. So overall, it was not only about maximum throughput. That's always nice, but it is about the overall experience. And even if Wi-Fi 7 has not this in the title, I mean, so it's more or less coming with Wi-Fi 8, multi-link operation was going already in this direction. So what is multi-link operation now? So if you just imagine you have more than one Wi-Fi link always available, what you can do with this, what was the idea behind? I mean, first of all, you can do link aggregation. So you can probably have two links with 23 gigabit per second and double the throughput theoretically. Or you can deal with certain congestions on the network so that you have still a stable connection on a certain throughput. The other thing is then you can really say you can select certain links. You have two links, for example, available, and the probability that both links are busy are quite low, so that you can always select one or the other links. And with this, you can really ensure low latency and, of course, improve the reliability. Next thing is really thinking more about, even if you have certain difficult RF conditions that you're probably losing packets and so on, that you have a kind of link redundancy, again, going in the direction of reliability. And if you think about Wi-Fi 8 is about ultra high reliability, you see multi-link operation fits very well in this. So this was more or less the idea, just on a nutshell, what is now specified in the 11BE, or what was specified. It is essentially, we have now so-called multi-link devices, which can serve more or less virtually up to 16 access point or stations. And multi-link device, and there's a special here, is splitted in a lower MAC layer and an upper MAC layer. And with this, you have a lower MAC layer, which is more or less typically responsible for the handling of the link, including link access and so on. And you have an upper layer, which is more about the scheduling and handling the different links which are available, just in a nutshell. And you have this on the access point side, and you have, of course, you need the related support also on the device side or on the station side, like on glasses or mobile phones and something like this. On the access point, we know this kind of handling from multi-band operation already a while, where they have more or less in dedicated RF change for the different bands, if you like. So what you can do now, they have introduced a couple of modes. I will explain a little bit more in detail, just two, to explain the principle. Later we will come to the different modes which are actually supported, which are standardized, and which are supported by the Wi-Fi lines. Here, this is probably the most powerful mode, and in a sense, easy to think about. You have two or more links, and you can use this both links totally independent. So which is called, you can simultaneous and independently transmit and receive. You haven't to care about what is happening on the other link, which also means that you need certain RF isolation between these links. Probably one of the reasons that you see in multi-link operation very often that the links are really in different bands, because if the links come too close together, then it becomes, from the interference point of view, very challenging. So this is the most powerful, as I said, from the RF design, probably most challenging thing. And what are the results now? And here I was taking some data from MediaTek that they published this in the white paper. If you are just compare now that you have, for example, a single link, 80 megahertz, and now you make multi-link operation with two 40 megahertz links, then you see that the throughput becomes just a little bit better, because from the capacity you have still the same, but under certain load conditions, you become a little bit better, because you have essentially two different mediums or resources available. And you can see this here also on the latency. If you have just the single links and the load becomes very high, then your latency becomes also very high. With multi-link operation, you become better. Even what is not shown here, of course, with this kind of approach, you can also have now two 80 megahertz links, which has some other impacts, or more or less double your throughput. Another thing is, if you don't like to avoid, for example, or it's too difficult to have this RF design challenge, you can have a more relaxed approach. And this is now the non-simultaneous transmit and receive. Here, it becomes more complicated, because here you have really to synchronize what you are doing. You can just transmit on these both links or receive on these both links at the same time, because otherwise you get in trouble with this kind of approach. What are the impact on this? You see this here again. It's sometimes very, very similar, just that you, of course, for the synchronization, you lose a little bit throughput, because you have to wait for the other links and something like this. So these are two of the main modes, at least if you have on both sides multiple radios available. This is then called multi-link, multi-radio operation, the first operation. if you see on these different modes that we have just as overview here, you have here multi-link operation, you have here multi-link, multi-radio, STR, this is what I showed at the beginning, and then you have non-simultaneous transmit and receive, this is here. These are the both multi-mode, multi-radio stuff. There's one extension which is enhanced multi-link, multi-radio. Here you have the special possibility to reconfigure certain links with a special command, for example, to go for certain links from a single special stream to several special streams. Now we have the problem that especially on mobiles, for example, they have not so many complete built RF change like an access point. They have probably just a kind of single radio. And for the single radio, then it is more a kind of switching, and this is called multi-link single radio operation. And in a simplest mode, they just switch between the links using the power mode from actives to standby, if you like. Also here they have an enhanced mode. This is enhanced multi-link single radio. Here you have the possibility to somehow split your single radio. For example, you have 2x2 MIMO. You can split your two antennas in two parts so that you can at least on a station side receive information on both, and then you can use this for more smart switching. If you look on the market now, what we see, as I said, all what I'm describing here is standardized by IEEE. Then we see essentially that the Wi-Fi 7 devices on the market, especially, of course, if they are Wi-Fi 7 certified, they are supporting this multi-link, multi-radio STR or this enhanced multi-link single radio. Multi-link single radio with the power mode is anyway more or less included. This is what we actually see here on the market. What are the challenges and where also test and measurement comes into the place? I mentioned this already, the RF design with interference and with all the different multi-links is very important. Then you have really to look on the timing, on synchronization for the interoperability, that all the devices work together, something that especially the Wi-Fi Alliance is addressing with interoperability testing. And then you have to have in mind that the standard defines the means how you are doing this and the tools to make multi-link operation, but how you are using this, how you are using the scheduling is the implementation from every vendor. And at the end of the day, you have to find out what is the best way, probably on a certain environment. Here AI also comes into place. You have to look on the overall power, you have to look on power consumption, and so on and so far. And of course, finally, also about interoperability. Looking now on Wi-Fi 8, you see here in Wi-Fi 8, we have a lot of new features, especially, I would say, small or tiny advancements all around the base of Wi-Fi 7 on the physical layer, like distributed tone resource units and so on and so far. What does it mean for multi-link operation? Certain features have also impact on multi-link operation needs to be considered. What is probably more interesting, that multi-link operation is also used for or leveraged for seamless mobility domain, so for mobility as defined in Wi-Fi 8. And if you think about integrated millimeter wave, which is, I don't know which Wi-Fi, which is a BQ standard, here we are also using multi-link operation. That means we have not new modes in Wi-Fi 8, at least in the moment, but we are using the capabilities which are defined in Wi-Fi 7. And with this, I would like to thank you very much. I hope this was, in the short time, a kind of introduction on Wi-Fi 7 multi-link operation, also the link to Wi-Fi 8. If you would like to have more information on our website, you can also find Wi-Fi 8, Wi-Fi 7, white papers, posters, and so on and so forth. Please feel free to join that. Thank you very much.
Thank you, Joerg, for sharing your thoughts. One of the questions that came in from the audience is for Wi-Fi 8 in environments of a single 320 megahertz channel, and of course, due to the higher interference, are coordinated beamforming and coordinated OFDM the solutions to make the MLO more efficient?
Yeah, I mean, this what you mentioned here are features which are actually in standardization in Wi-Fi 8. This coordinated stuff, I think it was originally part of Wi-Fi 7 and then was moved over. And of course, certain thing, or let's say in this way, all this works finally together, but I don't see the direct impact on this. Of course, it can improve, for example, the interference and the performance of single links, which are used again in multi-link operations. So in this sense, there's always a connection, but I don't see the direct influence, let's say in this way.
Okay, for MLO testing, what kind of test solution would you recommend?
Yeah, I mean, it of course depends what you are looking for. So typical thing, if you look on the RF design, for example, you would like to look what is the interference if you, for example, have on link A on the 5 gigahertz band and then other on the 6 gigahertz band, or two links in the 6 gigahertz band. You can easily do this with our non-signaling testing solutions. Could be with generators, analyzers, or also with our one-box solutions. If you are looking more on how the handling is, how the protocol for multi-link operation is supported, if you look on the performance, I would highly recommend a signaling tester where you can play with all these parameters and look in the same time on the handling of multi-link operation and also on the RF performance. This is, I think, a kind of new unique features that we provide with our CMX 500.
Okay. And IEEE is starting work on the next generation of Wi-Fi. What are your expectations on how MLO is going to evolve in that standard?
Yeah, I talked already about Wi-Fi 8. As we know, IEEE has just started to think about the next, which is most probably Wi-Fi 9. And what I saw so far, that's more or less the same kind of how to improve customer experience, reliability, stability, and so on. On the other side, in Wi-Fi 7, my impression is that this was a kind of first attempt in multi-link operation. Now, as this comes to the field, people learn a lot what works well, what not, what are the right mode, and something like this. So I would be not wondering if we see at least some improvements or adaptation of multi-link operation, and probably a wider use of multi-link operation in these devices. Probably also the stations, for example, mobiles are then supporting also multi-radio, and then something becomes easier. So something in this direction.
And are you seeing implementations or market demand for NSTR MLO modes?
Yeah, as I said, what we actually mainly see, because it is probably easier to implement, is exactly what the Wi-Fi Alliance is defining also for the Wi-Fi 7 certification. But as I said, with further progress and further learning, we can probably see also this enhanced multi-link, multi-radio is probably quite interesting for a couple of people or a couple of industries, let's say in this way.
Okay, we're almost at time. Joerg, thank you so much for your time today, and thank you everyone for joining. The next session, Wi-Fi 8 on the horizon, will start shortly. Stay tuned.
Thank you very much.